range. So you have this graph and somebody says, what is the domain and what is the range? Who can tell me just in words? Well, what is domain? Let's start with that. What does domain represent? Don't say range.
In between what values can X exist?
Yeah. What values is X allowed to be, essentially? Okay, right? Everybody agree with that? Okay. For this function, what is the domain? Just tell me in words. Yes. So it starts at -4 and it goes bigger, I guess for you guys, going bigger that way. All right. So in grade 10, when you learn it, some teachers just do this. X is greater than. Can it be -4? Why? It's an open circle, right? So that means the number is not included. So X is greater than -4. And then you'd say XER, which means X is bigger than -4, but X is any real number that is bigger than -4. That's what that means. That's the way it's taught a lot of times. Now, there's another way to write domain and range. It's called interval notation. So you would write it as smaller number always goes first on the left. So it'd be -4. And then to go to any number bigger than that, you write infinity. Smaller number always on the left, bigger number on the right. Then you have to put in brackets. So if it includes the number, have you guys, who's in Steve's class? Did you do interval notation? Somewhat. Okay, well, we're gonna do it right now. Mr. Steve did teach it. All right, so I totally forgot what I was gonna say. Including brackets and not including brackets. So a square bracket includes the number, and a round bracket or parentheses does not include the number. Okay, so is -4 included? No, so it's a round bracket. Can you ever get to infinity? No, infinity always has a round bracket or a parentheses, or a rounded bracket, okay? So that's how you would write it in interval notation, okay? What is the range of this graph? So, no, you're giving me interval. Okay, so it's the highest point is going to be 3, and then it just goes down, right? So it would be the old school way is y is less than, can it be -3? Yes, or equal to -3. And then you'd say YER. Do you know what the E means? In the set of, or belongs to the set of. R is real numbers. And it's not really an R. If you actually look at it in your book or something, it's like that, right? I just say R because it's easier to say R. +3. Sorry. Yes, it's less than or equal to +3. Okay. Interval notation, you would say smaller number always comes first. Which is smaller, -infinity or +3? So -infinity to +3. Can you ever get to infinity positive or negative? No, so it's rounded. Is the 3 included? So it's square. Okay. That's interval notation. Okay. All right. Do we feel okay with that? I think we should do a couple practice ones. Let's do. Why is this? Go. Domain and range, please. I'm going to use, when I do it, I'll interchange, but usually interval notation is what's used. But it doesn't actually, I don't really care. Ask the prof though, because she might care. I guess I could say her name, Ava, instead of just the prof every time. Are we ready? Okay, here's our new graph. Remember these graphs? Okay, are we ready? Domain. Just tell me in words, because the interval notation is going to be a little weird. What is x not allowed to be? Let's start with that. -2 and 2, right? Those are the vertical asymptotes. So you could write it like this. You go x is not allowed to be ±2, but it can be anything else. Now, if we're going to write this in interval notation, I'm going to shrink it down a bit if I can. I can't. There we go. Okay. If you think about it coming from the left side, it can be anything out here, negative infinity, all the way up to -2, right? Everybody agree with that? So if you're going to write that interval, that part of it, you're going to go negative infinity to 2. Can it be negative infinity? Like, can you get to negative infinity? So what bracket's going, or what am I putting around it? Parentheses or a rounded bracket. 2, can we, that's -2, sorry. Can it be a -2? No, so we put a rounded bracket. Then it skips over -2, and then it's anything between these two numbers, right? So how do I represent that in interval notation? Whoa. Yeah. So then it's round bracket. It's like that. And then again, you can't be +2, but then it can be anything else other than +2. So what would that be? 2 to infinity. Round bracket. Okay. Now your domain is all of these put together. Okay. So it's the union of those individual domains. That's a U. Okay? So it's the union of these domains, essentially. All right? So when in interval notation, you have to have this. So in some sense, this is way easier to write. You can say it can't be plus or minus 2, but it can be anything else. But if you're going to write it in interval notation, you have to write each sort of separate thing. Okay. Let's do the range. Let's do the range and let's just do the range in interval notation because it's a little easier. What's the lowest y value? Negative infinity, right? So it comes up from negative infinity all the way up to what's the next to the number it stops at? 1/4. Negative 1/4. I should have put a negative there, right? Negative 1/4. Okay. So we're coming from negative infinity to negative 1/4. What do I put around the infinity, the negative infinity? Round bracket. Can it be negative 1/4? So it's a square bracket. Okay. Then what does the graph do? Is there anything between negative 1/4 and 0? There's nothing, right? So then it skips to 0 to infinity. Can it be 0? Can it be infinity? No. Boom. All right. So there's this little gap here. And that's the range. Okay, does that make sense? The only real new thing is combining sort of domains if you want, and all you do is you put a U for the union of them. All right.
So you have to write like x,
you don't have to write it for interval notation because you're going from negative infinity here, right? But if you're doing this, like here, you would say y is less than or equal to negative 1/4, and you could say and y is greater than 0, like that, and then you could do yer. It can be any number other than that. Right? But if you're doing interval notation, you don't need to do that. Because if you just had a domain that was xer, that's the same as just saying negative infinity to positive infinity. So that covers you. Okay? All right. I don't know what to do. What do we want to do? Let's do what? Lines. What do you want to do? What do you think you need practice with? Peoples? Wow. Do you want me to just leave you to do it, or do you want me to run you through it? Leave it? Okay. What's the first step? Let's start with that. Factor. Go. I want vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept, POD. Please. Do you want me to run you through it, or are you okay? Okay, go. Run. Did you factor it? Did you get that? Okay. If you know what you're doing, just work ahead. All right. Whatever cancels is a POD, point of discontinuity. So the point of discontinuity occurs at x equals -1. Correct? Right? Is this coming back from Math 12? What? Point of discontinuity, whole. It's just a hole in the graph, an open circle. Point. It's called a point of discontinuity, but that's too many words, so we just say POD. So to get what the POD is, it's whatever factor cancels and makes that 0. So x is equal to -1. You then take that value. How do you get the y value at the POD? You put the -1 into what's left over, right? So -1 plus 4 is 3. So y is equal to -1 plus 4 over -1 minus 1. So I get 3 over -2, right? Yes? For the people that like decimals, which there should be nobody in this class that like decimals, you can write -1.5. I'll think less of you, but... So the POD occurs at -1 and -3/2. Yes? Really, I'm talking to the other class. Does that make sense?
Yeah.
Okay. You were in my class. You're supposed to know this. What's the vertical asymptote? Wow, that was... No. X equals +1. The vertical asymptote is what's left over and makes the denominator 0, right? The POD is the factor that cancels. The vertical asymptote is whatever is left over and makes the denominator 0, which is 1. X equals 1. Okay. We'll do y-intercept because that's straightforward. What's the value of x at the y-intercept? 0. X is equal to 0 at the y-intercept. So you just plug it into either the original, all the x's will go away, you got 4 over -1, so it's -4, or you can plug it into the simplified version, 4 over -1. You get -4 either way. So x-intercept is 0. That means y is equal to -4. There's your x-intercept, or y-intercept, sorry. Yeah. The x-intercept is when, the y-intercept is when x is 0. So you just put x is equal to 0 into the equation. All right. Horizontal asymptote, the HA. Those are those rules. What are the rules? You look at the degrees. So if you can either look here or you can look here, it doesn't matter. Either way, if they are the same, what do you look at? Leading coefficients, which are 1 and 1 or 1 and 1. It doesn't matter. So what's the horizontal? 1. I'm getting a lot of weird looks right now. Did you do right? What's that? No, hang on. Hey, stop.